We now prove two sets are equal. So here's the definition. Sets A and sets B, they're equal if and only if A is a subset of B and B is also a subset of A. That means A is contained in B and B is contained in A. And then we know that they have to be equal so that one can be subset of the other. So here set A is defined to be 3A plus 1 for some integer A. Set B is 3B plus 4 for some integer B. Is set A equal to set B? Again, it's always good to just write down some numbers from A and write down some numbers from B, and then you compare, right? To make sense of it. So let's write down a few. When A is equal to 0, then we get 3 times 0, which is 1. When A is equal to 1, 3 times 1 plus 1, which is 4. When A is 2, then you get 7. When A is, and you get 10. When A is negative 1, 3 times negative 1 is negative 2, negative 2 plus, 3 times negative 1 is negative 3, negative 3 plus 1 is negative 2. So actually they differ by 3, okay? They differ by 3. That's A. And for B, if you plug in different values of B, you get 4, and then 7, and then 10. And if you plug in B negative 1, then you get 1, and then negative 2, and so on and so forth. You can see that they're actually the same set, okay? They're the same set. Now, to prove the same sets, to prove they're the same sets, we need to prove set A is subset of B and set B is subset of A. So you need to prove two parts. So let's prove part 1. Set A is a subset of B. I'll leave part 2 as your exercise, but they're very similar, okay? So again, from earlier, the last problem, I hope that you know how to prove a set is subset of the other. So you're gonna let X be an arbitrarily chosen and typical elements from A. So basically, I'll just say let X be an element from A. So this really means it's just arbitrarily chosen and not a specifically biasly chosen. It's just randomly chosen elements from A. And of course, need to show this X is in B, right? Okay, and which means look at the definition of the B, which means X is equal to 3 times some integer plus 4. That's what you need to get to. Now, because X is from A, right? Then we already clearly, by the definition of A, then X has to be equal to, can be written as 3 times integer A plus 1 for some integer A, okay, for some A in Z. Why so? Again, by definition of A, of set A. Now, you want to show that this X can be written as 3 times some integer plus 4. So in other words, the X that you're chosen, which is 3 plus 1, right? You want it to be, can be written as 3 times some integer. This is integer that you need to figure out, plus 4. So I just, on my scratch paper, I try to do a little algebra, trying to figure out what this integer should look like. So I'm going to subtract both sides by 4. We have 3a minus, minus 4 at the same time, so minus 3, right? Equals 3 times the integer I'm looking for. And now when I divide both sides by this, by 3. So therefore this integer is going to be like a minus 1. So that's how I would get the idea what this integer has to be. So therefore, once I do that, I'm gonna say let b be a minus 1. Okay, where is b from? That's from my scratch paper. Okay, and then obviously b is integer because it's a difference of two integers. Okay, because of the difference, because I'm gonna say because difference of two integers is integer. Okay, integer. Now, and therefore 3 times b plus 4 is in sets B, and that because of that the way B is defined. So by definition of B, definition of sets B, and plus another reason, let's take a look at what 3b plus 4 is. And what is b? B is how I define it as a minus 1, so I plug in b a minus 1 plus 4, and you do the algebra, 3a minus 3 plus 4, you get 3a plus 1. That's what I expected, because that's how I design my this integer, right? So that these 3 times this integer plus 4 will end up with this form, 3a plus 1. And do you see that 3 plus 1 is actually the x, so which is equal to x. By the way, these are my scratch, the work on my scratch paper. I can kind of delete it. And now, therefore, this x is in B, because what is 3b plus 4, which is x, and 3b plus 4 is in B, therefore x is in B, right? And therefore I've successfully proved that A is a subset of B, because x is arbitrary element in A. Now I show that this arbitrarily chosen element is in B, therefore subset A is a subset of B. So part 2 you will have to do is to prove B is in A, and I'm gonna leave that as your exercise.